Greetings everybody. So today I wanted to make a video with a few more examples and perhaps a little bit more information on mutually exclusive events and or probabilities. Okay, so I want to do ultimately an example like this. Say we roll a six-sided die. So we start with maybe a fairly basic or straightforward scenario, and we roll one of these or whatever it is, like something fairly simple to start with. And you can roll a number less than 4. Okay, you can imagine that happening. And you can roll an even number. Like both of these could happen. But how would you conceive of or calculate the probability of rolling the dice and having the event turn up that you get a number less than 4 or you get an even number? Okay, so that's more complicated than just figuring out what are the odds of rolling a number less than 4 by itself, rolling the odds of an even number by itself. The or makes a more complicated event. And perhaps you can imagine what it would be like to roll a number less than 4 or an even number. But ultimately what I want to do is just talk about how we can calculate the probability of something like this. Now there will, for everything here, the type of compound event we'll be dealing with will have an or in it. All right. Okay, so let's talk about it this way. Okay, there's something called the addition rule in statistics, and we'll use to calculate or probabilities like I was suggesting. And here's the way that the rule works out. So say that like there's a verbal statement, and it says that we want to calculate the probability of A or B, you know, whatever that thing I just showed you was, rolling a number less than 4 or an even number, okay? Then the rule takes two forms, okay? We can say the probability of A or B happening is the probability of A plus the probability of B, okay? And we would use this equation if the events A and B are mutually exclusive. I'll talk a little bit more about that in a minute, okay? But just say that here's one form of the rule that we would use to calculate an or probability. And then there's this other one that looks similar, but it's got this extra thing on it. It says the probability of A or B happening is the probability of A plus the probability of B minus the probability of A and B happening. And we would use the second equation if A and B are not mutually exclusive. Okay, now at least in this video, I haven't mentioned what mutually exclusive means. I have in other videos. But so far you'd say, okay, if I'm calculating an or probability, I've got these two equations and I'll use one or the other, and it will just come down to me starting with knowing if the events in question are mutually exclusive or not. Okay, and then I use one of these or the other. Okay, so that's what I'm starting with. Now let's talk about what does it mean for events to be mutually exclusive. Okay, well, all right, here's the answer to that. Mutually exclusive, and I abbreviated that ME for the purposes of this, okay, cannot both happen at the same time. That's what it means to have events that are mutually exclusive. I'll give you an example. Here are some mutually exclusive events: being on Earth, event A, and being on the moon, event B. They can't both happen. I can't imagine any way that you could be on the Earth and also on the moon. Maybe you can be on the Earth, or maybe you could be on the moon, but how are you going to be in both places? Okay? So, all right, mutually exclusive events cannot both happen at the same time. So there's my example, but there are lots of events that are not mutually exclusive. So an example of that would be being on Earth and being in Texas. Those could both happen at the same time, right? You can be on Earth and you can be in Texas. It's possible. Just because you're on Earth doesn't mean you're in Texas, but it's definitely possible for both of these events to happen at the same time. All right, so hopefully that's simple enough that you could grasp what it means for events to be mutually exclusive or not. Okay. All right, so let's do this example, and here's one I took from MyMathLab. So we'll just have to accept this scenario face value. We're not in a position to argue with it or anything, but here's what it says. It says of the cartons produced by a company. So you might imagine there's some assembly line and they're making these cardboard cartons, and maybe some beverage goes in, who knows, all right, but they make cartons. And there can be defects on a production line in manufacturing. And it says of the cartons produced by a company, 6% have a puncture, so that's kind of a defect. It's got to be taken out of the production line. And 3% have a smashed corner, so that's another kind of defect. And 0.9% have both a puncture and a smashed corner. All right, so it's possible that they have a puncture. It's possible that there's a smashed corner. It's possible that both could happen. That's what I'm reading so far. And the question from here is find the probability that a randomly selected carton has a puncture or a smashed corner. Now, there's that word or, right? So this is an or probability. And oops. I clarified some of the numbers for you. Normally, like when we're given percents verbally, like we say 6%, we do the math with 0.06. So 6%, I'm going to, in terms of probability, say that that's 0.06, 3% 0.03, and 0.9%, well, I mean, percent means parts out of 100, so you know, any of these you could understand this way. That means 0.9 over 100, which is 0.009. That's why when you convert a decimal to a percent to a decimal, we just move the decimal left 2 spaces. Okay, so our probability experiment, what's happening here? We randomly select a carton. Events separately are A, the carton has a puncture, and B, the carton has a smashed corner. Are those mutually exclusive? Can they both happen? If these two events cannot both happen, we would say they're mutually exclusive, but these can both happen. I mean, it said right here in the setup for the problem, but that there's a certain number of these cartons that have both a puncture and a smashed corner. So they're not mutually exclusive. Now, what I want is to calculate the probability of A or B. You select the carton at random, it has a puncture or it has a smashed corner. Okay. So here is my formula for not mutually exclusive events and an or probability. Probability of A or B is probability of A plus probability of B minus probability of A and B. Okay. Now all of these numbers were just given in the question. Probability of A, the carton having a puncture, is 0.06. Probability of B, that it has a smashed corner, 0.03. And the probability of A and B, 0.009. All right, so those were all given, and I can read them right out of the formula. If I do the math, I get 0.081. That's the decimal I get. But I notice on this question that when I put my answer in, it says percent right there. It's got the percent sign right after where I put my answer. So 0.081, okay, well that's 8.1%. All right. Converting the decimal back to the percent, I move the decimal point right 2 spaces. Okay, now I hope that one is fairly straightforward example of the rule, okay, that we should use this rule, and 2, that you understand how, you know, to decide which one of these I would use. I would first decide if the events are mutually exclusive or not. Okay, so let's look at another one for a little more variety. So here's another one from MyMathLab. This one about rolling the die. This was the question I suggested at the beginning of the video. So you roll a 6-sided die. It's got numbers 1 through 6 on it. Find the probability of each of the following scenarios. So let's not read them both right now. Let's take them one at a time. First one is, what is the probability of rolling a number less than 4 or an even number? So there's the or again, okay? So when I do this first one, event A by itself will be roll a number less than 4, and event B will be roll an even number, okay? So before we go any further, let's say, are these mutually exclusive or not? That would amount to, can these both happen or not? If this event A and this event B cannot both happen at the same time, they're mutually exclusive. So can you roll a number less than 4 and roll an even number? Is that possible? That's definitely possible. If you roll a 2, then you would be rolling a number less than 4, and you would also be rolling an even number. So they're not mutually exclusive. They can both happen. So here's my formula for an OR probability in that case, the probability of A or B. Just like it said up there, what is the probability of rolling a number less than 4 or an even number? Okay, so that will be the probability of rolling a number less than 4. That would be rolling a 1, 2, or 3. So since there's 6 sides to the die, then that would be 3 out of 6. 3 possibilities out of 6 total. Probability of rolling an even number, that would be rolling a 2, 4, or 6. That probability is also 3 out of 6, because that's 3 possibilities out of 6 total. And then minus, what is the probability of rolling a number less than 4 and an even number? Well, there's only one way that that can happen. I mentioned before that, yes, you can roll a number less than 4 and an even number, but that would amount to just rolling a 2. That's the only way to do that. And so that's 1 possibility out of 6. All right, so here's my equation. If I add this all up, I get 6 out of 6 minus 1 out of 6. That's 5 out of 6, or 0.833. So like 83% chance that I roll this die and I get a number less than 4 or an even number. Okay. All right, so that's how I put my answer into this first one. Let's look at the second one. What are the odds of rolling a 6 or an odd number? Once again, it says "or" in it, so we know it's this kind of problem. We know that we're going to use one of these rules, okay? So let's think of it like this. Let's look at the events separately. That's always how I would do these, is instead of thinking about the whole thing, I think of what are the individual events. So it stated roll a 6, and the other event was roll an odd number, okay? Now, this time, I think these are mutually exclusive. They can't both happen. You can't roll a 6 and also at the same time roll an odd number. It's just not possible. You know, my example up here, can you be on the Earth and be on the moon at the same time? You can't. They're mutually exclusive events. They can't both happen at the same time. Okay, so here I'm dealing with mutually exclusive events, and the formula in that case was this one. If you have events A and B are mutually exclusive, the probability of A or B is just the probability of A plus the probability of B. Okay, so here's our applicable formula for that one. All right, so let's look at the numbers then. Probability of rolling a 6 or an odd number, okay, is the probability of rolling a 6 plus the probability of rolling an odd number. The probability of rolling a 6 is 1 out of 6, because there's only one way to do that out of 6 possibilities. Probability of rolling an odd number, well, that'd be a 1, 3, or 5. There's 3 ways to do that out of 6 possibilities. So 1 out of 6 plus 3 out of 6 is 4 out of 6. Reduce it to 2 out of 3 if you want to. As a decimal, 0.667 if I round it to 3 decimal places. Okay, so here we explore a little bit more about OR probabilities, our formulas, and what mutually exclusive events are, and then some how you go about thinking about some problems on MyMathLab. As a bonus, I want to do one more thing that really we don't have to have this first formula if you really understand what's happening. We could just use this one, okay? What I want you to realize, which I think would allow you to understand this even better, is that this formula would just become that one, okay? We could only rely on this one. Here's why. So I asked this question at the end of the video. What is the probability of A and B happening if A and B are mutually exclusive? So say events A and B can't both happen at the same time. What's the probability of A and B? All right, well, probability of A and B, if they are mutually exclusive, if it's impossible for them both to happen at the same time, A and also B, that's going to be 0. In statistics, something that's impossible has a probability of 0. All right, so think about like this. You could only ever use this formula because if A and B were mutually exclusive, this would become a 0 and it would drop out of the equation. All right, so you could think of it that way if you want to. You don't have to. I think it's a good thing to think about once you're all through it. But, if you want to just go about it like I have, decide if the events are mutually exclusive, pick the appropriate formula, calculate, then there's no problem doing it that way.